Welcome everyone. This is second video in Fourier series. In this video, I will talk about following topics: Dirichlet's condition, Fourier series for functions having point of discontinuity, and the very important topic of Fourier series expansion of even or odd functions in the interval minus c to c. In case if you are new to the channel, please subscribe it so that you get good quality video content. So first of all, let us talk about Dirichlet's conditions. So what are the Dirichlet's condition? Any function f of x can be developed or written as a Fourier series provided the function is periodic, single valued and finite. Second, function has a finite number of discontinuities in any one period. Third, function has at most a finite number of maxima and minima. So why these conditions are needed, that can also be discussed, but it will go beyond the scope of an engineering student. Usually a pure mathematics student discuss the requirement of Dirichlet's condition, but sometimes in examination they ask that write the Dirichlet's condition, or in multiple choice question also. So you need to keep this in mind, remember these three conditions. Next thing is that how to write the Fourier series for functions having point of discontinuity. So I will explain this through multiple examples, but before that just go through what is written here. So at a point finite discontinuity, x is equal to c, means at a point of finite discontinuity. Here let me write one word. So at a point of finite discontinuity, x is equal to c, there is a finite jump in the graph of the function, and both the limit on the left, that is f of c minus 0, and the limit on the right, that is f of c plus 0, exists and are different. At such a point, Fourier series gives the value of fx as the arithmetic mean of these two limits. It means what? That at x is equal to c, if x is equal to c is a point of discontinuity, then function value at x is equal to c will be given by 1 by 2 of f c minus 0 plus f of c plus 0. You might be thinking that what is this? So basically if I talk about f of c minus 0, it is the left hand limit of the function at x is equal to c. And if I talk about f of c plus 0, it is the right hand limit at x is equal to c. Since function is not continuous at x is equal to c, so we directly cannot calculate the function value at c. So to calculate the function value at c, we take the arithmetic mean of the left hand limit at x is equal to c and the right hand limit at x is equal to c. What does this basically mean? That will be clear to you in the next problem, but sometimes it is asked in multiple choice questions. So you remember this in you keep this in mind, that whenever they will ask you that if I have a point of discontinuity for the function at x is equal to 3, then what is the value of f of c? So this is how we calculate the function value at point x is equal to c. Now let us talk about this problem, and we will solve this completely, and you will be able to understand the discontinuity concept through this. So find the Fourier series expansion for f of x if the function is defined as in the interval minus pi to 0, the function is taking the value minus pi, and the interval 0 to pi, the function is taking the value x. So you can clearly see, I hope you understand the idea of continuity, that if I ask you that what is the left hand limit at x is equal to 0, because the function is discontinuous at x is equal to 0. So left hand limit is limit if I take x tends to 0 minus of f of x, then you can clearly see that in the left of 0 the function value is minus pi. And if I ask you what is the limit value in the right of 0, that is 0 plus of f of x, so that is equal to x, means it will be equal to 0. So in the right of 0 the function value is 0, in the left of 0 the function value is minus pi. So the function is not continuous at the point x is equal to 0. So in this case, how to calculate the Fourier series? But before I write the Fourier series, I want you to note one point, that if you look at the total interval, the interval is from minus pi. The interval is from minus pi to pi. So the length of the interval, because it is the x can take value between minus pi to pi, only point of discontinuity is x equal to 0. And here in the Dirichlet's condition we have highlighted that we can write the Fourier series if f of x has a finite number of discontinuity. So if we have one discontinuity, there is no problem, we can still write the Fourier series. So how to write the Fourier series? So first observation is, I hope you have noted that here the length of the interval, if I compare it with the interval alpha to alpha plus 2c, so here the lower limit, that alpha value is equal to minus pi, because the interval is from minus pi to pi, and alpha plus 2c is equal to pi. So that is the upper limit of the interval. So what is 2c? 2c is equal to pi minus minus pi, that is pi plus pi, so it is equal to 2 pi. So c is equal to pi, right? So it was not needed, I have done all this for you to understand that. I hope you realized that the length of the total interval is actually 2 pi. If you want to draw the graph of this function, can we quickly draw the graph of this function as well? So if I draw the graph, suppose we have this point that is minus pi, we have this point that is 0, and we have this point that is pi. So it is minus pi in case if I ask what is the function value from minus pi to 0. So if suppose I say that this point is minus pi, right? So function is taking the value from minus pi up to 0, that value is also minus pi, so something like that. And at 0 it becomes x. So then from 0 to pi the function is taking the value like this, right? So this point is pi. So you can see that the function is not continuous at the point 0, because it is taking a finite jump at the point that is 0, right? So in case if there is a point of discontinuity, how to write the Fourier series? So let's understand. And I also hope that you have noted that the length of the interval is from minus pi to pi, so the total length is 2 pi, right? So how the Fourier series will be written? So I write it, f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos n pi x by c, but here c is pi, so it will be a n cos nx plus summation n varies from 1 to infinity b n sin n pi x by c. I hope you understand this term, that is n pi x by c. So here c is pi, so it will be n pi x by pi, so that will give me just bn sin nx. Okay. So whatever I have written here with the red ink, if you do not write in exam or anywhere, it will not make much difference. This part I have written for you to understand. Okay. Now I need to calculate each of the Fourier coefficient one by one. So let us first calculate a naught. So how to calculate a naught? It is 1 by pi, and here the important thing is that there is a discontinuity at 0. So I usually, if I calculate a naught, do you remember the formula? The formula to calculate a naught is 1 by pi, and then we integrate it from minus pi to pi, because this is your total interval, minus pi to pi, and then you take f of x dx. Okay, but here it is not the case. Here what I have to write? I have to write integration from minus pi to 0 first, and in this interval minus pi to 0 the function will take the value that is minus pi, and then we will integrate, and then From the point 0 to pi, the function will take the value x, so I will write x dx. Okay, so what I will get? I will get 1 by pi, and if I integrate this, I will get minus pi, and integration of dx is x, so here the limit of integration is minus pi to 0, and plus if I integrate x, I will get x square by 2, and here the limit of integration is 0 to pi. So if I substitute the limit, what will I get? I will get 1 by pi minus pi, upper limit is 0 minus lower limit, so that is minus minus pi, so it will become plus pi, and here if I write, it will be 1 by 2, upper limit, that is pi square minus 0. So what did I get? I got 1 by pi minus pi into pi, that is minus pi square, and plus 1 by 2 pi square plus 1 by 2 pi square. So I get 1 by pi and minus pi square and 1 by 2 pi square, so I will get minus 1 by 2 pi square. So the final value is this pi square and pi will cancel, so I will get minus pi by 2. There was no space, but I hope you have understood it. So for your convenience, I write it in the different color, that a naught value that I have got is minus pi by 2. So this is the first thing that I have evaluated. Now I'm moving to the next page because we don't have the space. So the next thing we have to calculate is an. So to calculate an, again I will write 1 by pi, and here again we have to integrate in two parts. First is minus pi to 0, and here the in minus pi to 0 the function is taking the value minus pi, so I will write minus pi and then cos n pi x by c, so it will be cos nx dx. The value of c is pi, and then from 0 to pi I will write x, and then I will write cos nx dx. So here I am going to integrate it very slowly, because in the previous video I have got some comment like people are finding it slightly difficult to understand the integration. So what I will do, I will write 1 by pi, minus pi is a constant, out, integration of cos nx is sin nx by n. I am very slow here. Minus pi to 0 is the limit of integration, and plus here you have x into cos nx. So you are going to apply the integration by parts. I am using a different color. Let me use this green color here. So to just separate it, that how I will do. So I write this as a by integration by parts. So I write the first function. This is a very poor color, so let me change it to the red only. So I write first function x, then I write and let me use another bracket. So x, I write integration of cos nx dx, first function, integration of second function, minus integration of again integration of second function, that is cos nx dx, into a differentiation of first function, and then this whole thing is integrated again, right? And here I close the bracket, and for this the limit of integration, for this part the limit of integration is 0 to pi, and then I close this bracket. Okay, so continuing here, I will get what? I will get 1 by pi, and look at this very carefully. In this term, if you put the upper limit, and here I have used the red ink, so don't think it is not the part of the solution, right? Just I wanted to show you that this is a separate integral, so we have applied integration by parts. Now if I put 0 here, I will get sine 0. So sine 0 is basically 0, right? And if I put pi here, I will get sine n pi, means sine n minus pi, so that will be minus sine n pi. So we know that sine n pi is equal to 0, right? I hope you remember the result. Sine n pi is equal to 0 and sine 0 is also equal to 0. So both this term will become 0. So I will get minus pi 0 minus 0, so no need to write that. And then plus I have x, integration of cos nx is sin nx by n, and minus this term here will also give you sine nx by n, right? This term, right? And derivative of x is equal to 1. So I have to integrate sine nx by x again. So integration of sine nx by n is basically minus cos nx by n, right? So should I write it directly, or let me write one more step, otherwise you will get confused. So I am writing integration of cos nx dx is sine nx by n and then dx, and limit of integration here is 0 to pi, right? So in the next step I am going to write 1 by pi. This term I think is clear, not equal to, it will vanish, and here I will get x sine nx by n and minus 1 by n, and integration of sine nx is minus cos nx by n, so it will become plus 1 by n square cos nx, and in this case the limit of integration on the whole thing is 0 to pi. So let us put the limit now. We will get what? We will get 1 by pi. If I put the upper limit here pi, I will get the term sine n pi, which will make it 0. And if I put the lower limit here 0, so 0 into sine 0 is also 0, so this term will become 0. Now go to the next term, 1 by n square. If I put pi here, I will get cos n pi, and if I put 0 here, I will get cos 0, that is equal to 1. So finally what I have got? I have got 1 by n square into pi and cos n pi minus 1. If you want to write it further, you remember I have discussed in the previous video that cos n pi is minus 1 to the power n. So this will be like what? 1 by pi into n square and then minus 1 to the power n minus 1. Okay. So if you take n is equal to even, this will become 0. For n is equal to odd, it will become minus 2 by pi n square. That I will talk about in the next page. Now I have to calculate the Fourier coefficient Bn. So to calculate Bn, again I will write 1 by pi, and I have to integrate it from minus pi to 0, and in this case it is minus pi, and here I have to write sine nx dx, and then from 0 to pi I have to integrate x sine nx dx. I think now you are mature enough to understand this. So I will write 1 by pi integration of minus pi. Sine nx will give me minus cos nx by n, so this will become plus. So I will get cos nx by n, and limit is minus pi to 0. And now I will be writing this part directly, right? I'm writing this part directly. So I write x as the first function. Integration of sine nx is minus cos nx by n, and then you have minus, and again integration of sine nx, so that will minus will become plus, and integration of cos nx by n will become sine nx by n square, because derivative of x will become 1, right? And here the limit of integration is 0 to pi. I explained the steps in detail in the previous slide, so here I have written directly. So now I write 1 by pi. Now put the limits and all. If you put a limit 0 here, you will get pi by n, and cos 0 is equal to 1, and then you will put minus pi, so cos minus theta. I hope you remember cos minus x is equal to cos x. So if I put cos here, x is minus pi, I will get cos n pi. And now I go back to this bracket here. So if I put pi here, the upper limit, so this first term I will get minus pi by n cos n pi, and if I put 0 here in this, let me put this bracket, otherwise you will possibly get confused. So this is plus here, and I am using this bracket, so here I am writing minus, right? So minus pi by n cos n pi, and if I put minus 0, so this will become 0, because 0 into anything will become 0. Now if I go to this term, if I put n is equal to pi, the cos n pi will become 0, and if I put 0 cos, if I put pi, sin n pi will become 0, and if I put 0, sin 0 will become 0. So we will get this term also as 0. So basically what did I get? I got 1 by pi by n here, pi by n here, so pi by n can be taken common, and 1 minus cos n pi here and minus cos n pi here, so I will get minus 2 cos n pi. So the Fourier coefficient Bn I got is 1 by n, 1 minus 2 cos n pi. So I have got all the three Fourier coefficients now. Now it is the time to write the Fourier series. So what is the Fourier series? F of x is equal to a naught by 2. So a naught I got minus pi by 4. So minus pi by 2. So if I take by 2, it will become minus pi by 4. So it is minus pi by 4 plus summation n varies from 1 to infinity. And what is a n I have got? I have got 1 by pi n square, 1 by pi into n square, minus 1 to the power n minus 1. This is cos nx, right? And then plus summation n varies from 1 to infinity, 1 by n, 1 minus 2 cos n pi sin nx. I hope up to this there is no doubt. Now I am going to expand it to make it look more appealing. So here I am writing with a different color. So f of x is equal to minus pi by 4, and look at this very carefully, otherwise you will not understand. So I am using this bracket. If I take n is equal to 1 here, I will get minus 1 to the power 1, that is minus 1 and minus 1, minus 2, and I will get minus 2 by pi into 1 square cos x. If I take n is equal to 2, it will become 0, right? Because 1 minus 1 will become 0, means I have to take n is equal to 3. So I will get again minus 1 minus 1 minus 2. So I will get minus 2 by pi into 3 square, and here I will get cos 3x. If I take n is equal to 4, it will become 0. N is equal to 5, so again it will be like minus 2 by pi into 5 square cos 5x, and so on. And if I look at the next term, I will get what? I will get, if I take n is equal to 1, so cos n pi is how much? Actually 2, I could have written one more step here. Let me write it for your convenience. Minus 1 to the power n. So this term basically here is 1 minus 2 into minus 1 to the power n. So I will look at this. So if I take n is equal to 1, I will get 1 by 1, and cos pi, so cos or if I put n is equal to 1 here, so 1 minus 2 into minus 1, that is 3. So I will get 1 by 1 into 3 sin x. If I take n is equal to 2, so this will become 1 minus 2 will become minus 1. So I will get minus 1 by 2, right? So I will get minus 1 by 2 sin 2x. If I take n is equal to 3, then minus 1 to the power 3 is minus 1. So 1 and plus 2, that is 3. So I will get 3 by n. Okay. So I will get 3 by n. So n is also 3. So I will get 3 by 3 sin 3x. And similarly, if I take one more term so that you are clear, if I take n is equal to 4, so it will become 1 minus 2, that is minus 1. So I will get minus 1 by 4 sin 4x, and so on. This will continue. So this is the Fourier series expansion. But there is another part of this problem which I want to deduce, that we have to deduce that 1 by 1 square, 1 by 3 square, 1 by 5 square up to all is equal to pi square by 8. Okay. So how to deduce that? So this is very interesting. To deduce that, if you look at this expression here, you realize that you want to get 1 by 1 square, 1 by 3 square, 1 by 5 square, and here you are getting 1 square by 3 square by 5 square, means you want this term. So if I put x is equal to 0 in this expression, I will get what? I will get f of 0, right? And this term will become minus pi by 4, and you can see minus 2 by pi is a common term, so I can take minus 2 by pi common, and cos 0 will become 1, cos 3 into 0 will become 1, so I will get here 1 by 1 square, here I will get plus 1 by 3 square, yes or no, and I will get plus 1 by 5 square, and so on up to infinity. And if I put 0, sine 0 will all become 0, so all these terms will become what? It will become 0. So I have got f of 0 is equal to this, but the important point here is that how to calculate 0, and that is one of the point that I was highlighting here, that if I have to calculate the function value at 0 and function is discontinuous at 0, so to calculate the function value at 0, I have to take the average of f of c minus 0 plus means actually if I take c is 0, so 0 minus 0, so f of 0 plus 0. And I hope you are mature enough to understand that 0 minus 0 basically denotes that we are calculating the function value in the left of 0 and in the right of 0. So that will give me what? That will give me, so if you look at this function here, in the left of 0 the function value is minus pi, and in the right of 0 it is x, so it will be 0 only. That also I already have explained here. So one value I am getting minus pi and one value I am getting 0. So I will get a minus pi and plus 0. So basically I am getting minus pi by 2. So this if I put it in here, f of 0, I am getting minus pi by 2 is equal to, and what is the right hand side? That is minus pi by 4, minus pi by 4, and minus you look at this, minus 2 by 5, 2 by pi, and then the bracket that we are looking for, 1 by 1 square plus 1 by 3 square plus 1 by 5 square, and so on. So now I hope you are clear that I will bring this term in the left hand side, so it will become minus pi by 2 plus pi by 4, and here I will multiply it by the coefficient, that is minus 2 by pi, so that will become minus pi by 2, and that is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square, and so on. So in the end I am getting the final answer, that is 1 by 1 square plus 1 by 3 square plus 1 by 5 square up to infinity is equal to, this will give me what? This will give me minus pi by 4 into minus pi by 2, so that is equal to pi square by 8. So we have solved this problem, and I was very slow when I was solving this problem. So let us quickly summarize the two important things. One is that when we are writing integrating, we are integrating using the properties of that definite integration, that if I have to integrate it from minus pi to pi, that integration can be divided in different parts as per the requirement. And second important observation is that how to calculate the function value in case the function is not continuous at a given point. So this is how we can calculate the function value. Okay, so we are going to solve one more problem quickly, that find the Fourier series expansion for this function. So here I will not spend much time, I am writing the solution. So one thing it is clear here, that interval is minus pi to pi, minus pi by 2, then minus pi by 2 to pi by 2, and minus pi by 2 to pi. So the total interval is minus pi to pi. So here also the length of the interval is 2 pi. So what is the value of c? C value is equal to pi. So if I have to write the ft, the expansion, it will be also a0 by 2 plus summation n varies from 1 to infinity, and an cos, it is in terms of t, so nt, and summation n varies from 1 to infinity, bn sine n pi x or n pi t by pi, so that is sine nt. I hope you understand that in general we write sine cos n pi x or n pi t because it is in terms of t by pi because c is pi, so this will just be cos nt and sine nt. Now to calculate a naught, I have the formula, and the graphs and other things if you want to draw, fine, otherwise it is not needed. So I write it total c value is 1 by pi, and I have to integrate it in three parts. First is minus pi to minus pi by 2, limit the function is minus 1 dt. Then we have to integrate it from minus pi by 2 to pi by 2, and the function value is 0 dt. And then we have to integrate it from pi by 2 to pi, and that value is 1 dt, right? Now it is very much clear that if I integrate it, I will get what? I will get minus t, limit is minus pi to minus pi by 2. Here this is 0, so it will become 0, and this will become t, limit is pi by 2 to pi. So if I substitute the limit, I will get 1 by pi minus upper limit is minus pi by 2 and lower limit is pi, so minus pi by 2 minus minus pi, so that is equal to plus pi. And here the upper limit is pi and lower limit is pi by 2, so pi minus pi by 2. So what will I get here? I got 1 by pi and minus, so it is minus pi by 2 plus pi, so it will be plus pi by 2, but there is a minus, so it will be minus pi by 2. And from this I will get pi minus pi by 2, so it will be plus pi by 2. So fortunately I got this cancelled, so a naught value is equal to 0. So the first Fourier coefficient that I have got is equal to 0. Now quickly calculate the other two Fourier coefficients. So what is an? So an is 1 by pi, and here the interval is minus pi to minus pi by 2. In this interval the function is taking the value that is minus 1, so minus 1 cos nt dt. Then the next interval is minus pi by 2 to pi by 2, and this it is taking 0, so 0 into cos nt dt, and plus the last interval is pi by 2 to pi, and in this the function value is 1, so 1 cos nt dt. So if I evaluate this, it is very easy to evaluate because the functions are very simple. So it is like minus, and integration of cos nt is sin nt, so minus sin nt sin nt, limit of integration is minus pi to minus pi by 2. This will be 0, and this again will be sin nt, and limit of integration is pi by 2 to pi. I hope by now you have realized that most of the things are just related to integration. So I will get 1 by pi. So this minus, and if I put the upper limit in minus pi by 2, so I will get sine minus theta is minus sine theta, so I will get minus sine n pi by 2, and minus sine n pi, so again it will become plus, so sine n pi. I hope you remember this result which I am using here. Sine of minus x is minus of sine x, and if I look at this term here, I will get sine n pi and minus sine n pi by 2. So what did I get? I got 1 by pi. So here I got sine n pi by 2, and here I got minus sine n pi by 2. So this term and this term will be cancelled. I hope you got this is a minus sign here, and this minus will become plus, so this term will cancel, and here you will get minus sine n pi, and here you will get plus sine n pi, right? So this term will also be cancelled, so I will get 0, so I get 1 by pi into 0, so that is equal to 0. So good, I have got the Fourier coefficient an also equal to 0. A naught also I have got 0. Now let us see that what I am going to get in case of this bn. Okay, So to evaluate Bn, what we need to do, we need to again follow the same idea. What is the idea? That Bn is equal to 1 by pi limit of integration minus pi to minus pi by 2 minus 1 into sine nt dt. And should I write this? Or let me write, otherwise some of you will feel that I am not writing. So 0 into sine nt dt, and plus again pi by 2 to pi and 1 into sine nt dt. So you need to be very careful, otherwise make the mistake and everything will go down the drain. So here I have minus sine nt. So minus sine nt, if you integrate, integration of sine is minus cos, and we have already minus, so it will become cos nt by n, and limit is minus pi to minus pi by 2. This is 0, so no need to write, and here I will get minus cos nt by n, and limit of integration is pi by 2 to pi. So now let us do the limit substitution. So 1 by pi cos minus x is equal to cos x, so that we are using here. So if I put minus pi by 2, I will get cos n pi by 2, and if I put minus pi, I will get cos n pi, right? So this is the first part, and in the second, if I put cos n pi, I will get n pi and minus cos n into pi by 2. So are anything getting cancelled here? Cos n pi by 2 and minus minus plus cos n pi by 2, so it will be added. So here I have got, and this is minus cos n pi and minus cos n pi, so it will be basically be 2 times 2 by pi, and here I am getting cos n pi by 2 minus cos n pi. So the Fourier coefficient Bn I have got, a0 and an both become 0. So if I have to write the expansion now, what will be the expansion? Expansion will be f of t is equal to, first two terms has already been cancelled, so I write n varies from 1 to infinity, and in place of Bn I have got 2 by n pi, and here I am getting cos n pi by 2 minus cos n pi and into sine nt. So just if you want to leave it like this, fine, otherwise if you want to write it in the expanded form, I am writing. So 2 by pi is a constant, right? So I can take it out of the summation, and then for n is equal to 1, I will get 1 by 1, and what is cos pi by 2? If you take n is equal to 1, cos pi by 2, so that is equal to 0. And if you take n is equal to 1, cos pi, cos n pi is minus 1 to the power n. So you can write that as well, but if you want to calculate this, let me write this for your convenience. Cos n pi is minus 1 to the power n. So if you take n1, it will be 1, minus 1. So minus 1, so it will become plus 1, and then I will get sine t, right? If you look at the next term, so I will get what? I will get 1 by 2, because 2 by pi already taken, so I am 1 by n, so 1 by 2, and here I will get cos 2 pi by pi, so that is cos pi. Cos pi is minus 1, and if I take n is equal to 2 here, I will get minus cos 2 pi. So cos 2 pi is equal to 1, so I will get minus 1 again, and then I will write sine 2t. You need to do this yourself so that you don't get confused. And if I write the third term, I will get what? I will get 2 by n is equal 2, I already have taken out, so no need to write 2. I will write 1 by 3. So I write 1 by 3, and cos 3 pi by 2. Cos 3 pi by 2 is equal to 0. I hope you remember this result, that cos 2n plus 1 into pi by 2 is equal to 0, odd multiple. So for n is equal to 3, cos 3 pi by 2 will be equal to 0, and here I will get cos 3 pi, so that is minus 1 to the power 3, that is minus 1, right? So minus 1 will give me what? Minus minus plus 1, so I will get just 1 by 3, and here I will get sine 3t. so on. That is what I am getting. So if I write ft, the final answer, let me write in the best form, that I will get 2 by pi. The first term I am getting sine t, the next term I am getting minus 2 by 2, so here I will get that will cancel, so I will get sine 2t. Then the next term will be 1 by 3 sine 3t, and so on, right? So you can in case if you are in doubt, you can find the fourth term, fifth term, but I hope you are getting these things very clear, that if I write cos n pi is equal to minus 1 to the power n, so cos pi is equal to minus 1, cos 2 pi is equal to 1, cos 3 pi is equal to minus 1, cos 4 pi is equal to 1. So these things I hope is clear to you. Another thing I have used, that what is cos 2n plus 1 into pi by 2, odd multiple. So this is always equal to 0, means cos pi by 2, cos 3 pi by 2, cos 5 pi by 2, and so on. Okay. So this two problems we discussed. So let us move to the next idea. And this is the important topic, especially for exam and multiple choice question. The video will be slightly longer because I want to complete this topic in this video itself, so keep watching it. So if I talk about Fourier series expansion of even or odd function in the interval minus c to c, here it is important to note that we are focused on the interval of type minus c to c. And we know that if we have a interval like minus c to c, the Fourier series of any function is written like a naught by 2 and a n cos n pi x by c, n varying from 1 to infinity, and like this. And we also know that this is how a naught is written, this is also a n is written, and this is how b n is written. So this part we already know, there is nothing to be worried about. What is important here, that I am going to discuss two different cases, the case when f of x is even and the case when f of x is equal to odd. And these two slides are very, very important, so listen it very, very carefully. So if first case is if f of x is an even function. So if f of x is an even function, then how the a naught will be calculated? The a naught is calculated using the formula 1 by c minus c to c f of x dx, and we know the properties of definite integration. Do you remember this? I have discussed in the first video that if I integrate any function from minus c to c f of x dx, there are two possibilities, either it will be 0 or it will be 2 times 0 to c f of x dx. This happens when f of x is odd function, and this happens when f of x is even function. So here I am taking f of x as an even function, so the it will change from 1 by c, so it will become 2 times 1 by c, and the limit will change to 0 to c f of x dx. Now f of x is an even function, right? And cos function is also an even function, cos function, because cos of minus x is equal to cos x. So if I have to calculate a n, which is calculated using the formula 1 by c minus c to c f of x is even and this is even, so even into even is an even function, that also I have discussed. So it will become 2 times 1 by c, limit of integration from 0 to c, f of x cos n pi x by c dx. But what is important here is that if f of x is an even function, but sine x we know is an odd function, because sine minus x is equal to minus of sine x, that I know. So this is an even function, but sine n pi x by c is an odd function, so product of an even function and of an odd function is an odd function. And if we have to calculate bn, this function, that is fx into sine n pi x by c, in total this is an odd function, so the evaluation, the integral will be equal to 0. So the Fourier series expansion in this case will contain this will have a naught term and a n term, but the bn term becomes 0. Very important. What is important here? That in case if you are expanding a function fx, which is an even function, in the interval minus c to c, In that case, the Fourier coefficient Bn is equal to 0. I am putting 3 stars here. So it means what? That if Fourier coefficient Bn is equal to 0, it will not contain the sine term. It will, because in this case if Bn becomes 0, it means what? That there will be no sine term here. It will only have the cosine term. So this is what it is written, that thus if a periodic function f of x is odd, its Fourier expansion contains only sine term. It does not contain cosine term. Oh, sorry, I move to the next page. So what I am saying is that if f of x is even, then its Fourier expansion contain only cosine term. It does not contain any sine term. So in exams they may ask question based on this. Similarly, if I talk about the second case here, when f of x is odd function, so I don't have to explain much. A naught, in case if f of x is odd, will become 0. And since cos n pi x by c is an even function, but f of x is an odd function, so the product of this is an odd function. So if you integrate an odd function in the interval minus c to c, an will be equal to 0. So here we are getting a naught is equal to 0 and an also equal to 0 in case when f of x is an odd function, right? But we know that sine n pi x by c is an odd function and fx is also an odd function. So odd function into odd function is an even function. So to calculate Bn, if I use this formula 1 by c minus c to c, this is an even function. So using the property of definite integration, it will become 2 times 1 by c, and the integration limit will change from minus c to 0 to c. So 2 by c, 0 to c, f of x sine n pi x by c dx. So here the Fourier coefficient Bn will be evaluated like this. So it means what? That if f of x is odd, then Fourier expansion contains only sine term. It does not contain the constant, that is a naught and an terms. So to understand this, I am going to take one problem of both type, right? So first example that I am going to take is the example of an odd function, right? And here I will be writing the details so that you should not actually be worried about remembering the expression in this form. You just remember the expression in the original form and keep the properties of definite integration in mind. You don't have to remember these results, okay? So let me explain here. So if I talk about this function, if I write f of minus x, I will get minus x by 2, means that is equal to minus of f of x. It means what? That f of x is an odd function, and the interval also is suitable because it is minus pi to pi. We want the interval of the type minus c to c, because then only we can apply these properties of definite integration. So how to write the expansion? Fourier series expansion is written as a naught by 2. I am writing the general result. I am not writing like this will become 0 or that will become 0. It will just kind of confuse us. So it is better to remember the main result, and then using the properties we will reduce it. So a naught by 2, n varies from 1 to infinity, an cos n pi x by c, but here the length of the interval is 2 pi. Pi minus pi 2 pi is equal to 2c, so c is equal to pi. So an cos nx plus summation n varies from 1 to infinity bn sine nx. So let us calculate what is a naught. A naught will be 1 by pi, limit of integration is minus pi to pi, and f of x is x by 2 dx. Now this is an odd function, so this will become 0, right? And what will be an? So an will be 1 by pi, limit of integration is minus pi to pi, and f of x is x by 2 cos n pi x by c, so that is cos nx dx. Odd function into even function, so this is odd function, and integration of odd function from minus pi to pi will be equal to 0. So don't memorize that a naught and an will become 0. If you can memorize it, fine, but otherwise you can use this main idea also. So here, as I told you, that if f of x is an odd function, a naught and an will be equal to 0. Now what we have to do, we have to calculate bn. So to calculate bn, again I write 1 by pi minus pi to pi, f of x is equal to x by 2, and then sine nx dx. Okay, now odd function, x by 2 odd, sine nx odd, odd even. So the property is that it will become 2 by pi, limit of integration will change to 0 by pi. And one thing also we can do, let me write here, this 1 by 2 I can take outside of integration, and here I will get x sine nx dx. So this 2 and this 2 is cancelled, so I am writing here, so I have 1 by pi and x sine nx. So by now we are confident about integration by parts, so I write x first function, integration of sine nx dx minus integration of sine nx dx into differentiation of d by dx of x, and then we integrate the entire thing, and the limit of integration is 0 to pi. So what will I get? I will get 1 by pi. This will give me minus x cos nx by n. Integration of sine nx is minus cos nx by n, and integration of sine nx dx also will be like minus cos nx by n. So this minus minus will become plus, this will be 1, and we have to integrate this thing again, so I will get sine nx and by n, so it will become n square. Limit of integration is 0 to pi. Now let us put the limit. If I in the second term put the limit first, so if you put pi here, sine n pi 0, sine 0 0, so I will get what? I will get 1 by pi. And if I put upper limit pi here, I will get minus pi by n cos n pi. And if I put 0 here, 0 into anything will make it 0, and this we already have seen is 0. So what I got is this. Now this pi and this pi is cancelled. So what I got? I got minus 1 by n. And cos n pi is nothing but minus 1 to the power n. We have got this thing multiple times. So I have got the Fourier coefficient bn. So what is the Fourier expansion of the function? So x by 2, the Fourier expansion will be written as summation a naught and an is already 0, so n varies from 1 to infinity. Bn I have got is minus 1 by n minus 1 by n into minus 1 to the power n, and then sine nx. So if you write it in expanded form, it will look like what? X by 2 is equal to, if you take n is equal to 1, you can also consider it minus 1 to the power n plus 1, but anyway, n is equal to 1, so minus minus plus, I will get 1 by 1 sine x. If you take n is equal to 2, you will get minus 1 by 2 sine 2x. If you take n is equal to 3, minus minus plus 1 by 3 sine 3x, and so on. So we have got the final answer, that is x by 2 is equal to sine x minus 1 by 2 sine 2x plus 1 by 3 sine 3x, and so on. So this was an odd function, so its Fourier series contains only the sine term, it does not contain the cosine term. So in MCQ exam, they may ask you that if I write the Fourier series expansion of an odd function in the interval minus c to c, then it contains only sine term, cosine terms, or none of these, or both of these kind of questions may be asked. So before I end this video, I also want to calculate the Fourier series expansion of an even function, and I have taken an even function, that is f of x is equal to x square. So clearly, just for your convenience, I am writing the details. So f of minus x is minus x whole square, that is equal to x square. So it means that f of x is an even function, and here the length of the interval is minus L to L, so it is 2L, right? So what will be the Fourier series expansion? Again, I am not going to directly write, I am going to write the general result. So that is a naught by 2 plus summation n varies from 1 to infinity an and cos n pi x by L and plus summation n varies from 1 to infinity bn sin n pi x by L. I hope you are clear about this because we are comparing the interval from alpha to alpha plus 2c. So here alpha is minus L, alpha plus 2c is L. So the total length is L minus minus L, that is equal to 2L. So 2L is equal to 2c, so c is equal to L. So I am writing cos n pi x by c, so in place of c we have L here. So what is a naught? A naught will be equal to 1 by c, so 1 by L, limit of integration will be minus L to L, f of x is equal to x square dx. So this will be equal to 2 by L, limit of integration is 0 to L, x square dx. So that will give me 2 by L, x square will give me x cube by 3, limit is 0 to L. So I will get 2 by 3L into L cube. So 2L square by 3. So this is what sorry, the Fourier coefficient a naught is. Now evaluating the Fourier coefficient nn will be slightly more engaging because we have the x square term. So I need to be very slow so that you understand it properly. So and bn will become 0, that I will show later. So if I write an, I will write 1 by L minus L to L x square cos n pi x by L dx. Integration by parts. So I can write 2 by L 0 to L. I hope this is clear. Even function, product is even. So 1 by L can be written as 2 by L 0 to L x square cos n pi x by L dx. Expand it, 2 by L, expanding integrate using the integration by parts. First function, integration of second function. So cos n pi x by L dx minus integration of second function, that is cos n pi x by L dx into differentiation of first function, so d by dx of x square, and then this entire thing is integrated again and the limit of integration is 0 to L. So I will be writing some of the terms directly now. So it is 2 by L x square, integration of cos is sine, so it will be sine n pi x by L divided by the coefficient of x is n pi by L. So I have to divide this by n pi by L, means I need to multiply it by L by n pi, and minus this is the same term, so I will write L by n pi out, and here I will have to integrate because I will get sine n pi x by L, so I will write sine n pi x by L, and here if I differentiate it I will get 2x, so I am writing 2 here and I am writing x here, right, the constant I have taken. So this bracket is giving me x sine n pi x by L, and I have to integrate with respect to x. The limit of integration is 0 to L. Now I have to move to the next page, right? But before I move to the next page, I want to show you something which is very important here, that this part I already have integrated. So let us put the limit of integration in this. So if you put L here, the upper limit, you will get sine n pi L by L. So L will cancel, you will get sine n pi, means this will become 0. So the entire thing will become 0. and if you put 0 here in this, 0 square into this will also become 0. So by putting this limit, this entire thing will become 0, right? So this entire thing will go to 0. And you have 2 by L here, and you have minus 2L by n pi. So if you take this out, it will be L cancel, you will get 2 into 2, that is minus 4 by n pi. So I am writing the next term here. So I will get minus 4 by n pi, right? And in this we have the integration, limit is 0 to L. So I am writing integration, limit is 0 to L. And what is the other term? Other term is x sine n pi by x sine n pi x by L dx. I hope you have understood it. But as you know that we have to apply integration by parts again. So I write minus 4 by n pi, and this time I am going to write the steps directly. So x, or let me write the whole steps, sine n pi x by L dx minus integration of sine n pi x by L dx into differentiation of x, and then the entire thing is integrated with respect to x. Limit is 0 to L. So this will give me what? This will give me minus 4 by n pi. And here x, integration of sine, is minus cos n pi x by L, and I have to divide it by n pi by L, so I need to multiply it by L by n pi. And again this will give me minus, so minus minus plus, L by n pi is like constant, dx by dx will become 1. So here I will get cos n pi x by L dx. Limit of integration is 0 to L. So one more step, minus 4 by n pi, and here I will get minus xl by n pi cos n pi x by L. Integration of cos is sine, and so I will get here L square by n square pi square sine n pi x by L. I hope you got this, because if I integrate it, I will get sine n pi x by L, and that I have to divide it by n pi by L, so it will become L square pi square. Now it's time to put the limit. So I will get minus 4 by n pi, and if I put the upper limit here, I will get x, so I will get minus L square by n pi, and I will get L cancel, because if I put x is equal to L, so I will get cos n pi. If I put 0 here, 0 into everything will make it 0. In this term, if you put upper limit L, you will get n pi L by L, L cancel, sine n pi will become 0. And if you put 0, sine 0 is also 0. So I will just get this term, right? So let us close this bracket. Now minus minus plus, so I will get 4 times L square by n square into pi square, and cos n pi is minus 1 to the power n. So finally let us write the Fourier series. So what is x square? Okay, and one more thing before I write it, so that you will say that I have not written. So what is the next term, next Fourier coefficient? A naught, this is A naught, right? And the next Fourier coefficient that I have to calculate, this I calculated A naught, An, and now I have to calculate the Fourier coefficient Bn. So Bn will be equal to 1 by L minus L to L x square sine n pi x by L dx, and this will be equal to 0, because this is even function, this is odd function. So even function into odd function, the integral will be an odd function whose integral will be equal to 0. Okay, so finally write the expansion. So x square, what is the A naught I have got? A naught I have got 2L square by 3. So A naught by 2 will become L square by 3, and summation An I have got is equal to 4l square by n square into pi square. So 4l square by n square into pi square minus 1 to the power n cos n pi x by l, and bn I got 0, so no need to write. So this will give me what? This will give me x square is equal to l square by 3, and here 4l square by pi square is constant, so can be taken out of this. Here of course you know that n varies from 1 to infinity, and now you put the limits. So if you take n is equal to 1, minus 1 to the power 1, and so I will get minus 1 by 1 square cos pi x by l. If I take n is equal to 2, I will get plus, so I will get 1 by 2 square sine 2 pi, not sine, oh what I am doing, cos, don't get confused. So I will get cos 2 pi x by l. Similarly, if you take n is equal to 3, you will be getting 1 by minus 1 by 3 square cos 3 pi x by l, and so on. So I leave it as such. This is the Fourier series expansion. So ladies and gentlemen, this is like a very long video, 1 hour, more than 1 hour, but in this video I have covered the very important topic, especially the this topic of function being odd and even is very important, and function having point of discontinuity is also important. I have discussed 4 problem completely, and I discussed the concepts as well. Now the idea is that in this video I completed almost most of this content, so I will be uploading one video more related to the Fourier series, which will not be that long, which will be around 35 to 40 minute video. That is my expectation, and that will complete the Fourier series topic. So in case if you have enjoyed the video and have understood the things, let me know in the comment section, and share the video with everyone, because it is kind of very suitable for your understanding. I am writing all the details and explaining. So thanks for watching. Have a great day.